So we want FBG, AG, FG, CG, and BC. And we're given the diagram for this. All right, so before we decide on any sort of method for solution, what should we look at first about the system? Right, statically determinate, indeterminate, regardless if we think we want to start with a section cut or a joint or a point, is this statically determinate or indeterminate? Right, a pin at A, a pin at B, 4 reactions. So probably our best bet is to skip an external picture and jump right to a pin diagram or to a section cut. So this is where we want to make kind of the first decision of how we're going to proceed in solving this. We want 5 forces in total here. The rule of thumb, because we want only 5 of the members and not all of the members, probably we want to make at least 1 section cut. And often starting with a section cut is the best bet. So looking at this, where is a good place to start? There is not a unique solution or only one way to do this problem, but what would appear to be the most efficient way to start this problem? We look at the members we're interested in finding. Again, BG, AG, FG, CG, BC. By the rule of thumb I gave you, if we can, we want to cut through only 3 members in a picture. Again, we can make a second cut that goes through more, and that's okay, but in any one section cut, we should go through only 3. We're looking for 5. We can't go through all 5, so if we can go through as many as possible, up to 3, that's going to be our best bet. So where could we cut that's going to go through, if possible, 3 of the members? We can go through FG, we can go through CG, and we can go through CB. The benefit here is 1. By going through these 3 members, there are 3 that we're interested in, so all of the answers are going to be useful to us. And 2, because we skipped the external free body diagram, we'll have our choice. If I make this cut, I can take everything, I can make this cut and take everything kind of above it, or I could take everything that's below it. And either picture would give us equations that are true, but which one should I prefer because it was statically indeterminate? Right, so what I want to do is make this cut, and for my first picture, I want to take everything above it as my first free body diagram. Then we have these linkages that stay intact. $900 force, 1800, and another 900. Right, so this is unaffected by the cut, but then the 3 things we cut through, I also need to include. I can now see the force in BC. I can now see the force in CG. And I can see the force in FG. And then this is 1.5. Right, so we want to indicate the angle. These are this is horizontal, this is vertical. We can find this angle here that makes it the horizontal because we know it goes to the left 1.5. To get to G, it goes down by 3. So if we take the arctangent of 3 over 1.5, we're going to get about 63 degrees for that angle. All right, we can get our first 3 equilibrium equations then out of this. If we're doing it by hand, which one is a good one to start with? Well, X is, the problem with X, starting with X, is it's going to have CG and FG in it. So you could start there, that's fine, but you can't get a number right away. Right, I would start with the moment here. This one has the trouble that if you start with the Y, you'll also have 2 unknowns in it. So again, it's okay. But if you want numbers right away, if we take the moment around C as our first equation, then it's only going to leave us with 1 unknown, and we'll be able to get that as a number right away. So if we take the moment around C in picture 1, it eliminates these two forces. It eliminates the 900. I'll have 3 times 1800 plus 6 times 900. And then I have the vertical component of Fg and the horizontal component of Fg. So the horizontal component of Fg, if I just kind of lightly put it there, is going to be FFG cosine 63. And its distance away from point C is going to be the 3 meters. So the force is this times a distance of 3. Then I also will have a moment caused by the vertical component of FFG. So that will be the sine of 63. But that is going to have a perpendicular distance of the 1.5 from point C. So if we start with equation 1, the only unknown will be FFG. That should be plus. Yeah, both of these are positive. They're both going to be counterclockwise around point C. So if we solve for FFG, I think we might have a little bit different answers because of rounding. Even the 63 degrees, I think it was like 63.4. So your answer should be at least somewhat close to mine. I got negative 4,000 newtons, which means it's in compression. Again, your answer might be a little bit different. This was rounded, and the 63 was rounded. So if you're relatively close, then you're probably doing it correct. So FFG is in compression. You should get the negative 4,000. Any questions on the first equation? Now, it doesn't matter if we do x or y next. So I did x next. Because now we know negative FFG cosine 63. We know its value. Minus FCG, which we can now find. Minus 900, minus 1800, minus 900. According to the picture, it's negative FFG cosine 63. For the value of FFG, I will put in the negative 4,000. So when I do the math, it'll actually be 4,000 cosine 63. My unknown CG, I get negative 1780 newtons. So that also is in compression. So lastly, in the y direction, I'll have negative FBC minus FFG sine 63. Again, I now know FFG, so FBC will be my last unknown here. And FBC will be a positive 3570. So that will be in tension. We now know FG is done, BC is done down here, and FG is done. Or I already found that one, CG. Okay. So there's still two things we are left to find. We're obviously going to need another free body diagram. And we have a choice here. There's a couple of different ways we can do it. So what's another free body diagram we could draw that will hopefully include both of our remaining unknowns? Although even if it only includes one, we're still making progress. You could do two things. You can make another section cut. So one example would be, well, we will use the point, but one section we could make is if we cut through here, through these three members, that will give us the GA and the BG, and it would be a section cut, and we would also along the way find, well, we already know what BC is, so it would just give us a redundant equation. That would be one option, or, like I said, we can mix and match. We can also just take now a pin diagram at G. It's attached to four things, but at this point, we know what two of them are, and then the remaining two are the two things we are left to find. So we can draw our free body diagram of the pin in diagram G. one point I want to reiterate, whenever we're drawing a new diagram for a pin or a new diagram for a section, even if we already know some of the numbers, we want to draw the picture as though we don't know what the values are for internal forces. Now, if it's a support or an external force, those we can have the correct direction on. But here, even though, for example, I know that Fg is in compression, I'm still going to draw it assuming the same thing, assuming tension. So coming out from point G, I'll have that FFG at 63 degrees. I'll have AG also at 63 from the horizontal. I have CG, and I have BG. Now this angle is not 63 degrees. If I look at my triangle, it goes to the right by 3 and it goes down by 3. So this is actually a 45-degree angle for FBG. So in the picture I have 4 forces acting at G. There's no external forces. FG I know and CG I know from the previous step. So when I write the equations, then I'll be left with only really 2 unknowns and then the 2 left that I need to find. And if we look at the picture G, the 2 things we have left in here both have x components, both have y components. So unfortunately there's not really one direction to start with that's going to be better. So I'll just start in the x direction. From the picture, FCG is to the right. FFG is also to the right. Cosine 63. Minus the AG to the left. And plus BG cosine 45 to the right. In this equation, like I said, we have 2 unknowns. AG and BG are both in this one equation. I know CG and FG from before, so I can substitute those values in. If I go then to the final equation, the y direction for picture G, I will have FG sine 63 minus the AG sine 63 and minus the BG, and that'll be sine 45 for that one. 2 equations, each with both of my unknowns in them. So the solve step here, I do have to do a substitution or an elimination. I have to do a little bit more work for that. So if I solve these so we can get answers out in the end, I can find that AG will be at negative 5330. So that's in compression. And the last one, BG, I got a positive 1670. So that was in tension.